So remember that when we're doing the ratio test, we're looking for the limit as n increases without bounds of the absolute value of a sub n plus 1 over a sub n, and we want to know when this limit is less than 1. So for our purposes, I'm going to look for the limit as n increases without bound, and I'm going to substitute n plus 1 for all of these terms. So I'm going to have negative 3 to the n, x to the n plus 1 over n plus 1. And because I'm dividing by something that's going to be a fraction, I'm going to multiply by the reciprocal. So negative 3 to the n minus 1 times x to the n, and in the numerator I'll have an n. So continuing to simplify this, this will actually divide out with all but one of these terms, as will this. And so I'm going to have the limit as n increases without bound. This is going to be negative 3 times x times n over n plus 1. And these terms have absolutely nothing to do with n, so I can take them completely out. And also, because we're inside absolute values, I really don't care about that negative sign so much. So I've got absolute value of 3x times the limit as n approaches infinity of n over n plus 1, and this limit ends up being the big old 1. So I've got 3x in absolute values, and I want to know when it's less than 1. So because the absolute value of 3x has to be less than 1, x has to be less than 1/3, the absolute value that is. And so my radius of convergence is equal to 1/3. So that's part A. On part B, it says write the first 4 non-zero terms of the MacLaurin series for f prime. So we're going to be taking the derivative of this function here. So I'm looking at this function. I've got x minus 3/2 x squared plus 3x cubed. So f prime is equal to 1, because that's the derivative of x, minus 3x, because the 2 will cancel out that 2, plus I'm going to have 9x squared. And if I look at the next term, remember this was really 9x cubed over 3. They just did some simplification. The next one's going to be 27x to the 4th over 4, so this is going to be minus 27x cubed plus my dot dot dot. And one of the things that I notice here is that this is a geometric sequence, where my first term is 1 and my common ratio is negative 3x. And that's important because we're looking for a rational function to represent this. And I know that the sum ends up being the first term over 1 minus r, which for us would be 1 over 1 minus negative 3x. So that's really 1 plus 3x. And this is a wonderful representation for f prime. And of course, it was important for me to make sure that I put the first 4 non-zero terms of this. I put equality because the sequence does continue, but these are the first 4 non-zero terms here. For part C, we're dealing with the first 4 non-zero terms of the exponential MacLaurin series. So I know that e to the x is equal to the sum of x to the n over n factorial as n goes from 0 to really, really big. So this is going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus stuff. So there's my first 4 terms. And now I need to write a third-degree Taylor polynomial for g of x. So g of x is supposed to be e to the x times f of x, where e to the x is what we just put. So x squared over 2 factorial, x cubed over 3 factorial. And there's going to be stuff here, but none of this stuff is going to contribute to a third-degree Taylor polynomial. Only 30 powers and less will contribute. And this is going to be times x. So I'm going to have x minus 3/2 x squared plus 3x cubed plus stuff. And again, only stuff up to the 3rd power are going to contribute to a third-degree Taylor polynomial. And I'm just going to distribute 1 times all of this stuff. Well, 1 times x is x. 1 times 3/2 x squared is 3/2 x squared. 1 times 3x cubed is 3x cubed. And 1 times any of these higher order terms are going to be beyond the 3rd degree that we're looking for. So now I'm looking at the next term, x times all this stuff. Well, I'm going to have x times x, which is x squared. X times 3/2 x squared, which is going to be 3/2 x cubed. And x times anything 3rd power or bigger is going to give me a 4th degree term. And then I have my last term here, x squared times stuff. So x squared over 2 times x is going to be x cubed over 2. And if I do x squared times x squared, that's going to be too big. X squared times any of these other terms. And x cubed times any of these other terms is going to be too big. So this is it. This is the third degree Taylor polynomial. And I could simplify it, I could combine like terms, but I don't see a purpose to. It's not even going to try and simplify to anything nice if I look at this, so I'm going to leave it like this. So again, looking at points, you're going to get a point for trying the ratio test, and you're going to get a point for doing the ratio test successfully, and then 1 point for your final answer for your radius of convergence. You're going to get 1 point for your, let's say, your even power terms, and 1 point for your odd power terms or your negative terms, however you want to say it, and 1 point for recognizing the geometric sum. And then you're going to have 1 point for your Taylor series for e to the x. You're going to get 1 point for probably trying to distribute this out, and 1 point for getting the proper product of terms.